Hey guys, it's Kim K. Today I'm taking over Kim Now's Insta to talk to you about gas. I know, more specifically about kinetic molecular theory. And KMT describes behavior of gases in terms of particle motion. The particles are always in motion, just like how I have to be when I'm running from the paparazzi. I'm sorry, I had to change. Anyway, this theory can be used to describe the properties of solids, liquids, and gases. The 5 postulates are in fact based on the behavior of ideal gases. Ideal gas is a hypothetical gas that fits all the premises of kinetic theory. Thanks for tuning in. Okay, am I done with this yet, or?
Cut!
Hey girlies! Welcome back to our channel! Today we're going to be talking about the assumptions of kinetic molecular theory.
I know, so exciting with a capital E.
I know we're filming in a different space today, but I promise the content will make up for it.
Totally. You know, this kinetic energy just really keeps us moving. And so does Starbucks. But that's beyond the point.
So girls, according to yesterday's gossip about the 5 assumptions of KMT, gas particles has no volume and no kinetic energy is lost when gas particles collide with one another. Can you believe that?
OMG! Girl, in addition to that, the volume is empty space.
Wait, girlies. So that means the particles are smaller in size compared to the empty space. Oh my god, that's crazy. Also, there are no forces of attraction or repulsion between gas particles. These forces are called the intermolecular forces.
Crazy. Oh my god, didn't know that.
Wait, don't all gases have the same average kinetic energy at the given temperature?
Yes, ma'am.
Kinetic energy equals 1/2 mass times volume squared?
Can you say that a little bit clearer for our viewers?
Excuse me?
Kinetic energy equals 1/2 mass times volume squared.
Well, remember, this is only applied to ideal gases, although most gases will behave very similarly.
All right, ladies, let's go get our pumpkin spice lattes and get out of here. Bye.
Bye!
What doesn't behave according to the assumptions of KMT, but feels great when you want to feel drowsy? It's real gassy!
Yay!
Hi, I'm Dennis Tao, and this is my product, Real Gassy, the easy-to-use spray bottle for when you want to feel free. The secret behind Real Gassy is a revolutionary smelly gas particles that has volume, are not elastic when in collision, and allows for the repulsive and or attractive forces between molecules to take effect.
Real Gassy has helped me so much in my everyday life, eliminating the main thing that I have to deal with, my kids.
You heard it from the real mom, Peyton, that Real Gassy is so easy. Easier than counting the 1, 2, 3.
Gases have properties.
Whoa.
Expansion and compressibility. Rapid, constant, and random movements allow the particles to expand to fill the container. Since gases are mostly empty space, you can compress the particles into a smaller volume. Fluidity. Gas particles slide against one another with ease because they have the ability to flow. Density. That's all.
Density equals mass divided by volume.
Particles have mass and volume, so they have density. Gases have low density.
Low.
Effusion and diffusion.
Fusion. Diffusion.
Diffusion is the mixing of two substances caused by the random motion of particles. Effusion is the process where small particles pass through a tiny opening in a vacuum.
Whoosh.
Guys, are you ready for this HSBV ASMR adventure? Alright, today we will talk about liquids. Wait, what is a liquid? This is a liquid. Anyway, liquids have definite volume, takes the form of their containers, and are more ordered than gases, but are less than solids.
You can stop now.
Liquids also are not really expandable and compressible, but they have good fluidity, high density, and can diffuse, but slower than gas.
The properties of solids. Take a shape. Expansion and compressibility. They are not expandable or compressible.
Not expandable.
They hold secure positions with very little space between particles. Fluidity. Solids are not fluid. Density. Usually more dense than liquids. Diffusion.
Hi, y'all. My name is Erwin, and today we will be talking about phase changes. And Lord knows we need a change in this world. Shut up! Anyways, to change phase, you must either add energy or release energy in the form of heat. Phase changes include turning into a solid, a liquid, and a gas. Thank you. Resume.
Today in the Outback, we have some really interesting specimens fighting for their lives. They're fighting over who knows more about phase changes. The specimen's getting very close. The specimen is right behind us. Oh, wow. Well, to change phase, you must either add or remove energy in the form of heat. Adding energy is an endothermic change, such as melting, vaporization, sublimation, and removing energy is an exothermic change, such as freezing, condensation, and deposition. Energy is needed to overcome intermolecular forces to change into a disorganized state. Volatile liquids such as gasoline and acetone evaporate readily because they have weak intermolecular forces. Oh my god, wait. Something's interesting. Wait. During a phase change, all energy goes to complete the change. There is no rise or fall in temperature, even though there's heat being added. Now let's talk about names. Going from a gas to a solid is called deposition. Going from a solid to a gas is sublimation. A gas to a liquid is condensation. A liquid to a gas is vaporization. A liquid to a solid is freezing. And a solid to a liquid is melting. And the specimen is right behind me.